Hi, welcome back to video class 4. In my last previous video class, I solved the problem which is of n jobs on 3 machines. Okay, just if you look into the just particular problem, there they have given 5 jobs. Those 5 jobs will going to performing on 3 machines. Understood or not? And also there I have discussed why you need to convert your 3 machines into 2 machines. For the reason also I told, because for particular problems in sequencing, the first and foremost step we are going to follow is we are going to searching for obtain sequence order. For that you are going to apply for Johnson's rule. Whereas my Johnson's rule is not going to satisfy for if the problem is of n jobs on 3 machines. It is not going to be applicable. So that we need to convert your problem into 3 machines into 2 machines. Okay, for conversion from 3 machines into 2 machines, certain conditions are there. Okay, if any one of the condition is satisfied, then it is allowed for converting from your 3 machines into 2 machines. That condition is satisfied there, and also you are converted, and after conversion from 3 machines to 2 machines, you got the optimum sequence order for the particular problem. Okay, and also you have calculated your total elapsed time for the machines along with idle time for the machines. See, this is what you have discussed in last previous video class. Okay, in this video class again you are going to solve on problem n jobs on 4 machines. N jobs on 4 machines you are going to discuss now. Just look into the problem now. Okay, I am going to read the problem statement. Okay, there they have given 4 jobs 1 2 3 4 are to be processing on each of the 4 machines A, B, C and D in the order A, B, C, D. Okay, the order is given as well as sequence order. If it is different other than this, we need to follow for that. Okay, and the processing time usually is given in terms of minutes. Okay, find for minimum elapsed time and idle time for each machine. Okay, in this problem we need to calculate here total elapsed time along with idle time for the machines. Okay, jobs 4 jobs are there again. They are going to performing on 4 machines now. Now if you want to obtain optimum sequence order for this job, we need to apply Johnson's rule. Okay, now Johnson's will not going to be applicable because my problem is on 4 machines. It is only applicable when jobs are n along with 2 machines. Now I need to convert my 4 machines into 2 machines. For that we have a certain condition. What is that condition? Let us discuss now. Johnson's conditions here. In that, see here the condition I have written here, the minimum processing time on extreme columns here, extreme columns, what are those two? Machine A and machine D. In that we need to find out minimum processing time. See, if you go for machine A, the minimum processing time is 28. If you go for machine D, the minimum processing time is 32. Among these two, if we satisfy the condition that is greater than or equal to maximum processing time on middle column. What is the maximum processing on middle column? That is 18. Okay, that is 18. Among these two, is it 28 or 32? If we satisfy the maximum processing time in the middle column, that is middle column is nothing but machine B and machine C, then it is able to converting your 4 machines into 2 machines. Now let us see here 28. Obviously it is greater than equal to, sorry, it is greater than 18. The condition is satisfied. Again, if you go for, let us see whether satisfying or not. What is the maximum processing, minimum processing on machine D? 32. It is also going to be satisfied. That is always greater than 18. Here both the condition is satisfied. Then it is possible for converting your 4 machines into 2 machines. Okay. So similar to the condition when you are in 3 machines, I told the first and last machines we need to pick up, okay, minimum processing time that has to be greater than or equal to maximum processing of the middle machine. So that's what the condition we have discussed in n jobs on 3 machines for converting your 3 machines into 2 machines. For here we need to take up again same thing, first and last machines, the minimum processing time we need to pick up, that should be satisfied under the condition of greater than or equal to again the middle, the maximum processing of middle columns, nothing but the middle machines. Here in the middle machines are machine B and machine C. If it is satisfied, again we will go to converting your 4 machines into 2 machines. Okay, I will going to give converted machines will be given two names here, F1 and F2 here. last previous problems I have given G and H. There G is nothing but it is a combination of A and B. H is nothing but combination of B and C. Here I have given F1 and F2. How I have converted? Just look at here. As usual I have given original table I have written here 1, 2, 3, 4 job MA, MB, MC nothing but machine A, machine B, machine C and machine D. Along with processing time also I have given as for the given problem. Now how to convert now? Here we need to whenever have a three machines I have converted as a G now. The converted machine name as G. There we are going to add A, B. Similarly here the converted machine will be given as F1. It is a combination of machine A, machine B and machine C. Understood? And F2 is nothing but it is a combination of machine B, machine C and machine D. Now you got the idea now? Once again I am going to tell my converted machines will be, let us call as F1 and F2. F1 is nothing but it is a combination of machine A, machine B and machine C, whereas another one is known as F2, that is combination of machine B, machine C and machine D. It means that for particular job, so if example if I take for job 1, the job 1 is going to performing its processing time on machine A, machine B, machine C is nothing but 58 plus 14 plus 14. That has to be your added for F1 machine. So that's what I have done here. For F1, the job 1, the total process time is what now? We need to add the processing time of machine A plus processing time of machine B plus processing time of machine C. That is becomes 86. Similarly, for job 2, again you need to add all the processing times of machine A, machine B, machine C. That becomes now 58. For third job, you need to add all the processing times on machine A, machine B, machine C. If we add now 28 plus 12 plus 16 equal to 56. Similarly for second job 30 plus 10 plus 18, if you do it 58. Similarly for first job 58 plus 14 plus 14, if you add you will get 86. And last job is fourth job. All the processing time which is performing on machine A, machine B, machine C, you need to add now. That is 64 plus 16 plus 12. If you add you are going to get 92 minutes. Similarly go for again F2. F2 is nothing but what? It is a combination of machine B, machine C and machine D. Nothing but we need to add all the processing times of particular machine to be added now. For example here F2 I have written, okay, nothing but processing time of first job on machine B, machine C and machine D you need to add nothing but 14 plus 14 plus 48 will become 76. Similarly for second job is equal to 10 plus 18 plus 32, if we add we are going to get 16 minutes 60 minutes, sorry. And third job will equal to you need to add processing on machine B, machine C, machine D is equal to 12 plus 16 plus 44. If we add that becomes 72. Similarly for fourth job is going to be performing on machine B, machine C, machine D is equal to 16 plus 12 plus 42. If you do it, you are going to have a total of 70 minutes. See, this is how we need to convert your 4 machines into 2 machines. My converted machines are given name as F1 and F2. F1 will be combinations of MA, MB and MC, whereas your F2 will be combination of MB, MC, MD. Okay. Now we have 2 machines now. Now it is of order of n jobs on 2 machines. Now I can apply my Johnson rule for getting optimum sequence order. Just you look onto the table column F1 and F2. In that we need to apply Johnson's rule, okay, for getting optimum sequence order. Just you look into the column of F1 and F2 for calculating your optimum sequence order. Okay, Johnson's rule now we are going to apply now. What the first Johnson's rule step says that first you need to pick up minimum processing time before going for scheduling. Just to look at minimum processing time, which is that minimum processing time 56. Okay, if it is tie, then you go for choosing arbitrarily. There is no tie here. Okay, the minimum processing time is 56. Okay, once you got the minimum processing time, then again you go for step 2. In that step 2, the Johnson's rule says that if the minimum processing time is if it is available on first machine or first workstation, then we need to allot that particular job as early as possible. It means that we need to allot that particular job immediately from left to the right. Suppose if the minimum processing time is available on workstation 2 or machine 2, then we need to alert that particular job as late as possible. It means that we need to alert from right to the left. My minimum processing time is available on first machine. I need to alert my particular job immediately as early as possible. Nothing but from left to right. That is 56. Which job? That is third job. Then I allotted my third job. Again you go for minimum processing time after 56. Next is 58. Again that machine is that processing time is available on first machine only. Again I have to start from left only. Nothing but after completion of 3. Again I need to write 2 only. That is job 2. Again after that, which is the minimum processing time. See, one more thing, once a job is allotted, don't consider for further scheduling that. What are the, see, 3 2 is over now, you are searching for again 1 and 4. Again in that, which is the minimum processing time, again here the minimum processing time is, again if you search it here, you are going to get 70. Okay, that is 70 here. Yes or no? 70. See here, this processing time is minimum processing available on machine 2 now. Okay, whenever your minimum processing time is available on machine 2, that we need to apply as late as possible. Nothing but you have to start with right to left. That is on job 4. I have done job 4 now from right to left. The minimum leftover is 1 unit to right. This is my Optimum sequence order for a given jobs using Johnson rule. Okay, just now you go see, this is my first question. Not, and again in the question they have asked you to calculate total elapsed time along with total ideal time. Okay, just you look into the problem now. Again create new table, that is jobs. In that how many jobs are there, just as for followed in last previous problems. MA, MB, nothing but machine A, machine B, machine C, machine D. Okay, again in that you need to divide in and out. In nothing but here starting time for or receiving time for jobs to perform on machine, and out time in nothing but it is the finishing time, or else the jobs will be comes out on particular machine. Understood? Now jobs you need to be adapt as per sequence. Just now you got, that is 3 to 1 4. 3 to 1 4 I have written here. Okay, job say now nothing but here just you see here 3 to 1 4 of the job sequence order we got from using Johnson's rule. Nothing but third job is the first one will going to entering for machine A here. Okay, here the starting time for the machine for first job is always 0. One thing you remember, for machine A, whenever you are going to writing for in time for particular job, first job, it is always 0. Okay, now just look at the table now. How much duration you are going to performing your particular job, which job? Third job on machine A. You just see here machine A, which job? Third job. Just look at here, that is 28 minutes. Just I written 28 minutes. Nothing but out period will be 28 minutes. Nothing, finishing time will be how much? 28 minutes. Nothing, it means that after 28 minutes only the third job will be going to be comes out from machine A. Third job. Okay, that is the meaning here. Next, which job which is going to be entering for machine A? That is second. Nothing but after 28 minutes only, now the machine A will going to receive here job 2. Understood or not? Nothing but the starting period is now 28, because after 28 minutes only the job 2 will going to introducing for performing a machine A. That 28 becomes starting time for job 2. Okay, how much duration it going to performing on that? Out time now, which job? That is now second job on machine 2. Second job is 30. Okay, now 30, nothing but how? 30 plus 28, it become how much now? 58. 28 plus 30 will become 58. I got the idea or not now? Output 28 plus 30, it becomes 58 minutes. After 58 minutes only the job 2 will going to comes out from machine A. You got the idea or not? Again after 58 minutes only the job 1 will going to entering for machine A. Okay, that 58 becomes starting time for job 1 to entering for machine A. How much duration will going to performing your first job 1 on machine A, that is 58. Now you have to add 58 plus 58, it will become 116 minutes. Nothing but 116 minutes will going to take for receiving your job 1 out of machine A. Understand or not? Nothing but it requires 116 minutes to the job 1 to comes out from machine A. Now that 116 minutes becomes starting time for job 4 to entering for machine A. Now job 4, how much duration is going to performing on machine A, that is 64. Now 116 plus 64, if you add, it will going to get 118 minutes. 118 minutes. Now nothing but 180 minutes, 180 minutes. That 180 minutes is the total processing time for machine A. Nothing but after it requires 180 minutes for performing all the jobs on machine A. Okay, now you go for machine B. Now just look at here machine B. One thing you remember that here the ideal time, here now comes with terms called ideal time for machine B, machine C, machine D. See, after 28 minutes only the job 3 will comes out from machine A, and that will going for machine B. Until unless 28 minutes the job 3 will not comes out from machine A. Till that time the machine B is resting condition. That duration is called what? Ideal time. The duration is called what now? Ideal time. How much ideal time that is sitting here? Nothing but resting condition, 28 minutes. That becomes your starting time for receiving your job 3 on machine B. After 28 minutes only job 3 will be comes out from machine A, and that will be given for machine B. That 28 minutes will become now starting time for receiving your job 3. How much duration to going to performing on machine B, which is of third job? Machine B is 10 minutes. Nothing job, sorry, 12 minutes. 28 plus 12, if you add, you're going to get 40 minutes. 40 minutes. Okay. After 40 minutes only, job 3 will be comes out from machine B. Machine B now. Just be careful here. Already I told in the last previous video class, whenever you are solving your machine B, just you have to be careful about the output times of the particular previous machine, that is MA machine, that is machine A. Okay, just look at here. After 40 minutes only the processing for particular job, that is third job, is finished now. The job 3 processing will be done after 40 minutes only. For receiving, it has to wait for again 18 minutes, because during this 14 minute the jobs 2 still performing on machine A only. That's why again I cannot write 40 for starting time for job 2, because during that duration, that is 40th minute, the still job 2 is performing on machine A. The job 2 will be comes out from machine A only after 58 minutes. Now that has to write as a starting time for job 2. You got the idea or not? That's why the starting time for job 2 is 58 minutes. How much duration is going to performing in machine B now? Job 2. Job 2 is 10 minutes. Nothing but 58 plus 10 is equal to 68 minutes. Now that is 68 minutes only required for coming out of your job 2 from machine B now. Okay. Now nothing but 68 minutes. After 68 minutes again the machine B is ready for receiving your job 1, but I cannot write starting time as a 68, because during that period the job 1 is still processing on machine A only. It will comes out from machine A only after 116 minutes. Okay, till that time it has to be waited there only. Nothing but it has to be in resting condition. Okay, nothing but you have to write now 116 minutes as a starting time for job 1 for receiving on machine B. How much duration is going to performing on machine B now? Job 1, that is 14 minutes. If you add 116 plus 14 minutes, 130 minutes. 130 minutes. Okay, after 130 minutes only job 1 will going to comes out from machine B. Understood? Now I cannot write now 130 minutes as a starting time for fourth job receiving for machine B, because during that period the fourth job is still running on machine A only. That's why I cannot write now. I should write again 180 minutes. After 180 minutes only job fourth will be comes out from machine A. That's why I have written starting time for fourth job on machine is 180 minutes. And how much duration is performing now? 16 minutes. 180 plus 16 is equal to 196 minutes. That 196 minutes is the total processing time for machine B. Now go for machine C now. For machine B, the idle starting idle time is what? 28 minutes only. After 28 minutes only, job 3 will be receiving for machine B. Similarly for machine, how much duration is required? 40 minutes. That 40 minutes is nothing but it is idle time for machine C now, because during that time nothing but after 40 minutes only the machine C will going to receiving your first job, that is which job? Third job will be receiving for performing. Till that it has to be in idle condition. That's why your 40 minutes is called as idle time for machine C now. Now third job, how much duration to go performing on machine C? That is 16. 40 plus 16 if you add, that is 56 minutes. After 56 minutes only job 3 will be comes out from machine C. Okay, again while solving your machine C, just to look out the outcome of your machine B. That is very careful here. Okay, which are among, if you compare which is greater than, that will become starting time. Be careful that. Okay, now 56 is there. Just to check out for output time of machine B for job 2, 68. Now instead of writing 56 you need to write 68, because 56 minutes on, after 56 minutes only the machine C is get ready for receiving your machine 2. During that period time it is still performing in machine B only. That's why I should not write starting period as a 56 there. I should write 68 as a starting period for receiving your job 2 on machine C. How much duration is going to performing now on machine C? 2. 2 is 18. Now you have to add 68 plus 18. If you add it, you will get 86 for that. Again, see here, after 86 minutes, job machine C is ready for receiving your job 1, but it is still processing on B. That is after 130 minutes only it is going to be comes out from machine B. Now I should write 130 minutes as a starting time for job 1. Okay, I should not write 86 now. Till that duration it is to be considered as ideal time. Okay, now 130, how much duration do you want to performing your first job on machine C? Job 1 on machine C is 14. Now 130 plus 14, if you add it, 144 minutes. After 144 minutes only job 1 will comes out from machine C. Now again after 144 minutes it is ready for receiving last job, that is fourth job, but it is still, see, after 196 hours only it comes out from machine B. Till that it has to be wait. That duration is called as idle time. Again it has to wait for certain minutes. Okay, now I should not write 144 as a in time. I have to write 196 as a in time for fourth job for machine C. How much duration is going to be acting now? Fourth job on machine C is 12 minutes. Now we add 12 minutes, it will become now 208 minutes. 208 minutes now. Okay, see, this is the 208 minutes is become now total processing times on machine C. Now you go for last machine, that is what? Machine D now. Okay, now what is the output time for third job on machine C? Is 56 minutes. Nothing but after 56 minutes only the job 3 will be comes out from machine C. Till that time it is waiting, no, that duration is called ideal time for machine D. How much duration it is? 56 minutes. That duration is called ideal time for machine D. That will be considered as a starting time for job 3 for receiving your particular job on machine D. That is which job? That job. Now 56 as the starting time, and how much duration is going to performing your job 3 on D. Job 3 is how much? D on D is 44. If you add 56 plus 44 it will become 100 minutes. Again while solving your machine D, just be careful our output time of machine C. Here 50, after 100 minutes only it will going to receive your job 2 on machine D. Okay, now 86 on output time for machine 2, and here output time for first job is, sorry, third job is 100. Nothing but you have to compare these two, which are having greater value, that you need to write. Here 86, 100 is because after 100 hours only it will going to receive a job 2. Okay, that I need to write as a starting time, and how much duration to going to performing your job 2 on machine D, 32 minutes. 100 plus 32 is equal to 132 minutes. Okay, now just again be the same scenario again. Okay, one third after the 132 minutes, the machine D, it will going to ready for receiving your job 1, but is job 1 is still processing on machine C in that duration. That's why I should write 144 minutes, because after 144 minutes only job 1 is ready for going for machine D. Now that 144 is becomes now starting time for machine, sorry, job 1 on machine D. Okay, now how much duration is going to performing your job 1 on machine D is 48 hours. Again I should write 144 plus 48 hours. If you become, it will become 192 minutes. I can see here after 192 hours, so 192 minutes, machine D is ready for receiving your last job. That is job 4th, but it is still processing on during that period. It is processing on machine C. After 208 minutes only, it will comes out from machine C. That's why I should write 208 as a starting time for job to receiving on machine D. Job is job 4th job. Okay, now starting time is for 208 for job 4 to entering for machine D. Now how much duration to go to performing job 4 on 42? If you do it 42 minutes, if it become 250 minutes, that 250 minutes is called as your total elapsed time or total run time for entire machine. The minimum elapsed time, that is also called as the total run time, that is 250 minutes. That is the question they have asked. Write down the minimum elapsed time, nothing but this is the minimum time that is required to perform all the jobs on 4 machines. That how much duration, that is 250 minutes. The last one question they have asked is, now we need to calculate now idle time for the particular machines. Now so what is here, you need to know how to get your idle time in the machines. Now total processing time or total run time along with the processing times of individual machines, if we do it along with idle time, we're going to get your idle time of particular machines. Now idle time of machine A, the total run time is how much, 250 minus the processing time of machine A. If you do it, you'll get 70 minutes. 70 minutes will be the idle time for machine A. Okay, now idle time for machine B. Now 250, that is total run time, minus 196 is the processing time of machine B, along with certain idle times will be available for machine B. Okay, how, see here 28 minutes plus here I have written 250, that is net total run time, minus 196 is the processing time of machine B, plus your idle times. Now because the machine B has to wait for 28 minutes for receiving your job 3 on machine B, that is become idle time, plus again 18 minutes by receiving your job 2 on machine B, it has to wait for 18 minutes. How, 58 minus, always idle time will be calculated. For beginning it will be hesitant, you have to write. For second again idle times you need to do like this, 58 minus 40, you're going to get 18. Again for receiving your job 1 on machine B, it has to wait for certain it has to wait certain minute. How many duration, that is 48 minutes. How, 116 minus 68, if you're going to get 48 minutes as a idle time for that. Again for receiving your 4th job on machine B, again it has to wait for 15 minutes. How, 180 minus 130, you have to subtract your in time with out time, you're going to get 15 minutes. If you do it, you will get 198 minutes as a idle time for particular machine, that is C machine. Now for machine C. Now machine C is, again you have to write maximum runtime. How much, that is maximum runtime, 250 minus the processing time of machine C is 208 plus 40 minutes. Obviously it has to wait, because for receiving your 3rd job on machine C is, it has to wait for 40 minutes. I have written 40 minutes. And again for receiving your job 2 on machine C, it has to wait for how much, 68 minus 56, you will going to get 12 minutes it has to wait. Again if you go for receiving your first job on machine C, it has to wait for 130 minutes minus 86, you will get 44. Again for receiving your 4th job on machine C, it has to wait for 196 minus 144, it will get 52 minutes, that will become idle time. These are all idle times. If you do it, you're going to get 190 minutes as a idle time for machine C. Now you go for last machine, that is called idle time for machine D. Now here 250 minus 250, because that is total processing time, minus if you get 0 plus idle times you have to write 56 minutes you have to write, because that is starting period, because after 56 minutes only job 3 is going to be come for processing, that is after that duration is called what, idle period time for machine D. 56 minutes has to wait for receiving your job 3 for machining. First job need to be performed, that is 56 plus again here 100 minus 100 0. Again for receiving your first job on machine D, it has to wait for 144 minus 32. If you do it, you're going to get as a 12 minutes. Again for receiving your fourth job on machine D, it has to wait for 208 minus 192, that is 16 minutes. If you add again, if you do a simplification, you're going to get now 84 minutes as the idle time for machine D. See, this is how you're going to calculate your idle time for individual machines. See here, total elapsed time, nothing but the last processing time what you got for the machine D, that will become total processing time, nothing but that is called total elapsed time or run time for the entire machines, nothing but after 250 minutes only every job will going to performing on all the 4 machines, that what called run time. Okay, idle time nothing but the total run time minus processing time of the individual machines. If you do it, you're going to get idle time, along with you need to add your idle time for that. For A, there is no idle time available for in between the jobs, because for the first machine you're going to immediately after one you're going to again supplying for second, third, fourth. There is no waiting for receiving your jobs there. Wait, other machines will be there, no B, C, D. Those are going to wait for certain period of for receiving for performing the particular jobs. That we need to add if you're going to get idle time for the particular machines. See, this is how you're going to calculate your idle time for the particular machines. Okay. Again, if you have any doubt regarding in that, please comment on Google Classroom, so that I'm going to rectify and I'm going to solve that particular problems what you are going to got in the next video class. Okay. Again, in next video class you're going to solve graphical method for particular problems. Okay.